In this video, we're going to just be exploring some of these functions in R related to using logistic regression. So this is mostly stuff that's kind of presented throughout the book. A little bit I mentioned in the slides, but I'll kind of go through an example here as well. So I'm just going to be using the spam data that is mentioned at the end of chapter 17. I'll be doing a couple things of my own in addition to some things that are already done there as well. So this is data that's found in a particular package. So I'm just going to kind of call that package up. And so the context here is this is somebody's collection of emails. I guess they have about 4,600 emails here, where some of them have already been labeled as spam emails. Some of them are just labeled as normal non-spam emails. And so one thing that we might be interested in doing here is whether certain characteristics of the email might actually signal the likelihood of it being a spam email. In other words, is knowing some of this information going to increase the likelihood that it's probably a spam email versus it not being a spam email with emails of other characteristics. So there's a lot of variables here. We can't even necessarily scroll through all of them in the preview here. But most of these have to just do with how frequently certain words are used in a particular email. There's also some information here about how often certain characters are used. So for example, how often a semicolon is used or a round bracket. And then some of the ones, I guess we can get to them over here. How often capital letters are used, like total number of capital letters used. Some other things that I'm honestly not quite sure what everything means here. And then finally, the type of email of it being either labeled as spam or not spam. And so we can use logistic regression as a way to kind of model the likelihood of it being spam given certain predictor information. So let's go ahead and just create a simple model first, where we're going to use the total number of capital letters in an email as a predictor of whether the email might be spam or not. And so if I kind of create this model and then look at a summary, I can see that this seems to be highly correlated with the likelihood of the email being spam. That if we do a z-test here, now granted we have a lot of email, so it's really easy to get a low p-value when I have a lot of observations, even if the effect it has is pretty small. So let's just kind of keep that in mind here, that this doesn't actually tell me how strong a predictor this is, as much as that I'm just really confident that it does have some predictive power, and that the parameter probably isn't 0 here. But I can also make a graph to kind of look at this a little bit more carefully. So what I'm going to do is use Ggplot. So this is a departure from the book. So I'm actually going to use Ggplot to do this. One thing that I do need to mention is that before I can plot this data, though, I do need to make the type variable numeric, and I would like to make it zeros and ones. So I'm going to change this to as.numeric and set it equal to itself. But I also need to subtract 1 as well, because this step right here is going to make this variable 1s and 2s, when I want to make this 0s and 1s. So I'm just going to subtract 1 as well and set spam $type equal to itself with this change made. And so then if I were to look at the spam type variable, so if I just kind of do this real quick, oops, here we go. You'll notice that all the values are going to be 0s and 1s. These are all 1s because it's just the first 1,000 and the data is already sorted, but the other ones are actually 0s. So then if I continue here, I can create a Ggplot where I look at capital total as my predictor on the x-axis, type on the y-axis as 0s and 1s. I'm going to go ahead and jitter this data just because there's so much of it. Again, there's 4,600 observations, so I'm gonna jitter this with a kind of height jittering, and I'm also gonna set alpha, the transparency, down pretty far as well, just so we can kind of see more about where the data is concentrated. I just have some labels here. I have a theme added just to make it a little bit cleaner because I don't like the default gray background on these plots. And then I also have a geom smooth line to plot the logistic line as well. Now, if I did not include that, by the way, so let's say that this is kind of canceled out for a second. So if I kind of do that here and make this plot, this would just be kind of the scatter plot itself. And so I can see sort of that the likelihood of spam does seem to be a little bit higher for these higher capital letter counts. It's kind of hard to tell, but I think there's a whole lot of emails that are concentrated right here, right around 0, whereas the extension's a little bit farther with the spam emails. There needs to be more capital letters in some of the spam emails. Now, if I want to plot that logistic line as well, I can do that with geom smooth. One thing to notice here is that I do need to add the glm method. So instead of an lm method, now it's going to be glm. And then there's this argument here. It's a little bit kind of funky, but it's method.args equals list, and then family equals binomial. So this is what's going to tell R that the particular GLM that I'm fitting is going to be a logistic generalized linear model, and so this family equals binomial is that particular choice. So if I plot this here, I should get that line of best fit. Oh, I need the plus sign. That's what's missing here. So if I try that again, I will get a logistic regression fit, and I can see the likelihood of it being spam is predicted to be a lot higher here as capital letters goes up. When capital letters is quite low, it's a little bit more likely to be not spam, but that likelihood pretty quickly changes there for these higher capital letter counts. I can also fit a more complex model as well. And I'm just realizing right now that I think I forgot to. Yeah, I just forgot to add. Sorry, I had to take a second there to figure out. Yes, so I did it correctly on the first one. I just forgot to add it here. So I just want to add family equals by, oops, that's not spelled correctly. Family equals binomial to specify that I'm making a logistic model here. So the GLM function does set this up to be a generalized linear model, but I do still have to identify which type of generalized linear model I'm going to be making here. So family equals binomial makes that selection for me. So just like the one that we did up here has that argument there. So if I create this model, I'm going to just make a summary of this model as well. Notice that every once in a while you get these convergence errors as well. So this can kind of give you a warning that sometimes this happens a lot with logistic regression, that certain parameters are not estimated very well just based on how many predictors I added and the nature of the data that I have. So just kind of keep this in mind that when you get this warning, you may not have some super well-fitted predictor estimates, and that you can kind of play around with the model, taking different variables out to see what makes that error go away, and that would help you kind of identify which of these predictors that might be the case that's kind of bothering the model the most. So anyway, I fit a model here, and I got a summary. And so maybe one question that I'd like to know is whether or not this model is adding a statistically significant amount of predictive power in comparison to the simpler model that I already did first. So I did the GLM CAPS model first, and so I'm going to just run an ANOVA, specifically I'm running a likelihood ratio test with the ANOVA function to compare these two models to see if the more complex model is explaining a statistically significant amount of additional predictive power in predicting spam here in comparison to the simpler model. So I'm going to run this ANOVA. I get a very small p-value signaling that yes, it seems to be that these additional variables are probably adding something, at least one of them is. So I am kind of gaining some predictive power with this fuller model in comparison to the simpler model, that I feel confident that at least one of those predictors is probably adding to this model. I can also use these models for prediction as well. So let's say that I want to use the more complex model. Again, I need to add that family equals binomial. Just forgot that here as well. So to specify this is a logistic model. So I'm going to fit that model, and then I can kind of plug in some particular predictor values and make an estimate for the likelihood of the email being spam, given this is the information about that particular email. So I'm going to kind of set this first just because it gets a little bit clunky to write it all in here. So I'm just going to write obs equals a data frame with these 4 predictors specified. And then I'm just going to plug that into the predict function. Notice also, again, we do need to specify if we want the probability of the email being spam, we need to specify the type to be response. The default option is actually type equals link. And this would give me the log odds of the email being spam rather than the actual probability. So just make sure you make that change if that is what you'd like to predict, which is likely what you want to do. And so we do get a warning. Again, there's a little bit of a convergence question about the predictors that we used, but we do get a probability that the email is spam given this information about the model. I could do the same thing, by the way, with the simpler model. So if I want to use the GLM CAPS model, I could do that as well. So I'm just going to change this. And this one, so this is what I'll do. Let me kind of cancel these out. And then I'll just write the new prediction below it. So I'm going to predict the likelihood of spam from just the CAPS model as well. In which case, I don't need all 4 of these predictor variables specified. I just need data.frame for, let's see, it's going to be capital total equals some value. So we'll just say 200. And then now we can use this to predict the likelihood the email would be spam given this information. And so it looks like the likelihood is about 37% in this case, which is a little bit lower. So this other information I added would suggest that maybe with this other information, it maybe increases the likelihood the email is spam. But when this is the only information I have, this would be kind of the expected likelihood of it being a spam email. So we're not really going to talk about, by the way, classifying responses. So in other words, something that you might want to do with the model is to then kind of make those final predictions that you take your model and then you go to some new data and then you classify observations as either being ones or zeros based on your model. So you can read about that in the book if you'd like. It's fairly straightforward, I think, to kind of understand. It's a very logical next step. We won't really be covering that on the exam or the homework, but just kind of wanted to mention that as, maybe being something you might be interested in reading about. But otherwise, we are done.